Hi everyone, in this video we're going to be learning about one of the circle theorems on angles formed or subtended by the same arc. More specifically, we're going to be learning that provided they share the same arc, then the angle at the center of the circle is 2 times bigger than the angle at the circumference. But now, before I actually state that rule and work through the two examples that you see here, I want to make sure that everyone's comfortable in recognizing which angle is being subtended by which arc. And for that, I'm going to spend a minute or two to define two things. The first of which are angles at the center. And I'll just write that, angles at the center. Here's the idea. Let's say I have a circle, something looking like that, and I'll say its center is right here. By considering 2 points on the circumference of this circle, so let's say one there and another one could be here, I can think of the circumference of this circle as being split into 2 arcs. One of the arcs is this part of the circumference, that's this short arc right here, and the other arc would be this part of the circumference. That's the longest of the two. And now if I join these 2 points to the center of the circle, so if I draw a radius here and another one here, then that creates 2 angles at the center. And we say that each of those angles is subtended or formed by one of these 2 arcs. This angle at the center is formed by this arc here, which we can see here is the shortest of the 2 arcs. And in fact, I'll draw over it in red as well. There we go. So this red angle is subtended by this red arc. The second angle at the center is this angle right here. And that angle is subtended by this longer arc right here. And to be consistent, I'll draw over that in blue. There we go. Okay, so those are the 2 different types of angles that can be subtended or formed by arcs at the center. But what about angles at the circumference? And that's the second thing I want to talk about before we actually look at the rule. Angles at the circumference. To picture things well, this time I'll draw 2 circles. So that's one, and its center would be right here. And in fact, I'll just copy that. There we go. There we go, that's another one. Okay, now once again, my starting point is 2 points at the circumference of the circle. So I'll place one there and one there. And just as it did here, placing these 2 points at the circumference of this circle creates 2 arcs. A short arc here and a longer arc right here. But now to picture angles at the circumference, I'm now going to place a 3rd point along the circumference of this circle. And for this first one, I'll place that point on the longest of the 2 arcs. And it could be anywhere on that arc, but I'll place it right here. Now by joining that 3rd point to the 2 points I had previously placed at the circumference, it creates what we call an angle at the circumference. And that would be this angle right here. And once more, we say that this angle is subtended or formed by an arc. And the arc that's forming this angle would be this arc at the bottom here, the shortest of the 2 arcs. And in fact, I'll draw over that arc in red, like so. And it's worth pointing out that by placing my 3rd point on the longest of the 2 arcs I started off with, it created an angle at the circumference which is formed or subtended by the shortest of the 2 arcs. And the opposite would have happened if I had placed the 3rd point on the shortest of the 2 arcs. And so let me illustrate that with this second circle. And I'll set things out the same way again. I'll place 2 points at the circumference of this circle, like so. And it therefore creates 2 arcs, this long arc up here and this short arc down here. And now I'll place my 3rd point along the shortest of the 2 arcs, so anywhere along this arc here. And I'll place it right here. And just as I did for this first circle, I'll join these 3 points, like so. And now we can see that by joining these 3 points, I've created an angle at the circumference. That's this angle right here. And we say that this angle is subtended or formed by this arc, which is the longest of the 2. And I'll draw over that arc in blue. That's this arc right here. And so notice that in this case, by placing my 3rd point on the shortest of the 2 arcs, it creates an angle at the circumference which is subtended by the longest of the 2 arcs. And it's also worth pointing out that angles at the circumference of a circle can either be acute or obtuse. If the angle at the circumference is an acute angle, then it's being subtended by the shortest of the 2 arcs. On the other hand, if the angle is an obtuse angle, then it's being subtended or formed by the longest of the 2 arcs. And it's worth keeping that in mind, Because to answer questions like we have on the right-hand side here, the fundamental step is to figure out which arc is subtending the angles. And one of the ways to figure that out is by focusing on the angle at the circumference. So remember, if the angle at the circumference is an acute angle, then it's being formed by the shortest of the two arcs. On the other hand, if it's obtuse, it's being formed or subtended by the longest of the two arcs. Okay, hopefully it's now safe to say that we know about angles at the center and angles at the circumference, and we're comfortable in recognizing which arc subtends them. So let's learn the theorem. And in fact, I'll go ahead and write theorem here. Just as I did for the angles at the circumference, I'm going to draw two distinct circles. And so I'll draw one right here, and I'll say that its center is here, and I'll just copy this guy. I'll start with this circle here, and I'll split the circumference into two arcs by placing 2 points on it. So I can place a point right here, and another point right here. And I'll join each of these 2 points to the center of the circle, like so. And so we can see here that this circle's circumference is split into 2 arcs. We have a long arc here and a shorter arc here. And by joining the 2 points at the circumference to the center, I've created 2 angles at the center. And so now let me add a third point on the circumference of this circle to create an angle at the circumference. And for this first circle, I'll add that third point on the longest of the 2 arcs. And now I could place it anywhere on this arc, but I'll place it right here. Now I join this third point to the other 2 points on the circumference. So that would look like this. Okay, now what I want you to do is to focus on the angle at the circumference. So that's this angle right here. Notice that this is an acute angle, and it's being subtended by the shortest of the 2 arcs, this arc right here. And because this angle is being formed by this arc, this is the arc we're going to be focusing on for the angle at the center of the circle. Remember, this theorem is about angles formed by the same arc. And so once we've found which arc is subtending the angle at the circumference, we need to make sure that we're considering the angle at the center, which is formed by the same arc. In other words, the angle at the center we're going to be considering here is this angle right here. And now finally, what the theorem of the angle at the center tells us is that the angle at the center is 2 times bigger than the angle at the circumference. In other words, if I go ahead and call the angle at the circumference x, then the angle at the center will be 2x, or 2 times x. And for the sake of being able to say that we wrote down the theorem, let me write that rule on the right-hand side here. The angle at the center is twice the angle at the circumference. And that's the rule. Notice here that because both of these angles were subtended by the shortest of the 2 arcs, we end up with a quadrilateral which looks a bit like an arrowhead. But let's see what it looks like when both of the angles are subtended by the longest of the 2 arcs, and I'll do that using this second circle here. Once more, I'm going to split this circle's circumference into 2 arcs, and I do so by placing 2 points on its circumference, so one there and another one here. And so I now have my 2 arcs. I now join these 2 points to the center of the circle. There we go. Which again creates 2 angles at the center, one here and one here. And now I place my third point on the circumference of the circle, but as I said, this time I'll place it on the shortest of the 2 arcs. And anywhere along this arc will do, but I'll go ahead and place it right here. I now join this third point to the other 2 points on the circumference, like so. And just as it did for the first circle I have here, joining these 3 points has created an angle at the circumference. And that's this angle right here. And now the question which will allow us to figure out which angle at the center we have to work with. And that is, which arc is subtending this angle at the circumference? And I'm sure you can probably tell by now that it's the longest of the 2 arcs that's forming that angle, which I'm drawing over right now in blue. And if it helps, remember that if the angle at the circumference is obtuse, which it is here, then the arc that's subtending it is the longest of the 2 arcs. Okay, now that we know which arc we're dealing with, we can quickly tell that the angle at the center we have to work with is this angle right here. And so we have an angle at the center and an angle at the circumference, which are both subtended or formed by the same arc, and we can therefore use this rule. And we can state that the angle at the center is 2 times bigger than the angle at the circumference. So if I call the angle at the circumference x, then the angle at the center would be 2x. All right, now that we've gotten all of the theory out of the way, let's go ahead and work through these two examples. For this first example, and in fact I'll write example 1 here, example 1, we need to find this unknown angle A. And notice that this angle is at the circumference of the circle. And notice as well that we're given an angle at the center of the circle, which is 150 degrees. Now to potentially use this theorem and find this unknown angle A, the first thing we need to do is ask ourselves which arc is subtending this angle. And looking at this circle, it doesn't take us too long to see that the arc that's forming this angle is the arc I'm hovering over right now. And in fact, I'll highlight it like so. That's the arc. And now that we've located which arc subtends the angle at the circumference, we need to ask ourselves which of the two angles at the center is this arc subtending. And it doesn't take us long to see that that's this angle right here, the 150-degree angle that we're given. And so we can state that this angle A at the circumference and this angle of 150 degrees at the center are formed by the same arc. And consequently, we can use the rule we've just learned. And we can state that the angle at the center is 2 times bigger than the angle at the circumference. And we can state that 150, that's 150 degrees, is equal to 2 times A. All we have to do now is solve this equation for A. And to do that, I just need to get rid of this 2 that's multiplying A. And for that, I divide both sides of this equation by 2. And so on the left-hand side, we have 150 divided by 2, which is 75, and that's 75 degrees. And that's equal to 2A divided by 2, which is just A. And so we can write A equals to 75 degrees. Done. Okay, let's look at the second example. And I'll just write example 2 here, example 2. And once more, we're given a circle and we need to find the unknown angle A. And in this case, the unknown angle is one of the two angles at the center. We can also see here that we're given an angle at the circumference of the circle, which is 130 degrees. And so to figure out which of the two angles at the center we can work with, we need to ask ourselves which arc is forming this 130-degree angle. And by now, I'm sure you can tell right away that the arc that's subtending this 130-degree angle is this long arc I'm highlighting right now. And if it helps, remember, because the angle at the circumference is an obtuse angle, the arc that forms it is the longest of the two arcs. Okay, now that we know that we're dealing with this long arc, we can see that the angle at the center that we can use this theorem with is this angle right here. And since this angle is called A, I'll go ahead and call that angle B. And so this angle B at the center and this 130-degree angle at the circumference are both formed by the same arc. And so we can use this rule and state that B, the angle at the center, is 2 times bigger than the angle at the circumference. In other words, we can go ahead and write B equals to 2 times 130 degrees. And so B is equal to 260 degrees. Finally, now that we know what B is, we can calculate what angle A must be by using the fact that angles around a point must add up to 360 degrees. That is, A plus B must equal to 360 degrees, and since B equals to 260, this becomes A plus 260 equals to 360. Now subtracting 260 from both sides of this equation, we get the answer. A is equal to 100 degrees. And we're done. And there we go. We now know about the angle at the center theorem. Remember, if the angle at the center and the angle at the circumference are formed by the same arc, then the angle at the center is twice the angle at the circumference. And that's it for this tutorial.